Good day, everyone. I am Chabelita Aco. For today's presentation, we're going to discuss our topic, which is certainty factor. So, what is certainty factor? Certainty factor is a popular way to use in uncertainty management rather than using bias reasoning. It is also used as an alternative to fuzzy logic. Certainty factor is known as CF. It uses a number to measure the expert's belief. The maximum value of certainty factor or CF will be positive 1. This means it is definitely true, and the minimum value is negative 1, which means it's definitely false. Let's see how certainty factor being implemented in my scene. MyScene is one of the earliest expert system developed in medical area, and it has these certainty factors in it. The CF value used is between negative 1, which is representing definitely not, to positive 1, which represents definitely true. The value between negative 0.8, negative 0.6, and so on, it does have some other representation. For example, almost certainly not, probably not, maybe not, unknown, and so on. Consider this kind of form of rules. Rules normally being presented in if-then form. So if this if-then rule being incorporated with some CF value, so the CF actually represents the belief that hypothesis is true given that the evidence has occurred. Two functions that has been the basis of certainty factors are the measure of belief and the measure of disbelief. These measures are being identified by the experts. So the experts will see how much that they believe this hypothesis is true given this evidence is true. The expert usually constructs these measures based on the probability of things happened. So they will identify the prior probability of the hypothesis and the probability that hypothesis will be true given the evidence is true. The measure of belief and disbelief usually range between 0 to 1. So the total strength of disbelief is actually calculated into the certainty factor using this formula.
Hey, good day everyone. I am Jerome Felecio to be continue discuss about certainty factors. So first we are going to discuss the example of certainty factors. So here is the first example as considered a simple rule. So if E is X, then B is Y. So an expert may not be absolutely certain that this rule holds. Also suppose it has been observed that in some cases, even when the if part of the rule is satisfied, an object taken on value of x, object v can be acquired some different rule as value z. So if a is x, then b is y with a certainty factors of 0.7 with another value of b is z with a certainty factors of number 0.2 rather. So the certainty factor assigned by a rule is propagated through a reasoning chain. This involves establishing the net certainty of the rule consequent with the evidence and the rule antecedent is uncertain. So this is the formula of getting the certainty factors. So here is the example. If sky is clear, then the forecast is sunny with a certainty factor of 0.8, and the current certainty factor of sky is clear is 0.5. So certainty factors of H and E is equals to 0.5 represents the sky is clear times 0.8 as the certainty factors, so equals 0.4. So this result can be interpreted as it may be sunny, so 0.4. So next is for conjunctive rules. So such as if evidence or E sub 1 and evidence En, then hypothesis of certainty factors. So here is the given formula of getting the conjunctive rules of certainty factors. So the AND logic here is the AND logic given is getting the minimum value of the evidence. So for example, if sky is clear and the forecast is sunny, then the action is wearing sunglasses with hypothesis of CF 0.8, and the certainty of sky is clear is 0.9, and the certainty of forecast of sunny is 0.7. So here is the example of getting the equation to find the certainty factor. So let us first find the minimum value of the evidence. So ang minimum value ni sa between 0.9 and 0.7. So minimum value is 0.7 times the hypothesis of certainty factors of 0.8 is equals to 0.56. So for the disjunctive rules such as if evidence E sub 1 or evidence En, then hypothesis H of certainty factors. The certainty of hypothesis H is established as follows. So here is the example or a given formula of getting disjunctive rules. So the OR logic here is considered as to find a max value of the evidence. So the difference between and OR here is when AND logic here is to find a value evident of minimum value. So the OR here is to getting the max of the evident. So thank you. So the next example will be discussed by Miss Madelo.
Good day, everyone. I'm Michelle Marie Madelo. I'm going to discuss the continuation of disjunctive rules and certainty factors. So this is the example of disjunctive rules. If sky is overcast or the forecast is rain, then the action is take an umbrella, which has the certainty factor of 0.9. The certainty of sky is overcast is 0.6, and the certainty of the forecast of rain is 0.8. Using the certainty factor equation in disjunctive rules, we will be able to find the certainty factor of this example. In this equation, we need to find the maximum value between E sub 1 and E sub 2, which is 0.8, will be multiplied to the certainty factor of hypothesis, which is 0.9. So the answer will be 0.72. Suppose the knowledge base consists of the following rules. Rule number 1, if A is X, then C is Z, which has the certainty factor of 0.8. Rule number 2, if B is Y, then C is Z, which has the certainty factor of 0.6. So when the same consequence is obtained as a result of execution of two or more rules, the individual certainty factors of these rules must be merged to give a combined certainty factor of a hypothesis. So what certainty should be assigned to object C having the value of Z if both rule number 1 and rule 2 are fired? If we have two pieces of evidence, A is X and B is Y, from different sources, which is rule number 1 and 2, supporting the same hypothesis, then the confidence in this hypothesis should increase and become stronger than if only one piece of evidence has been obtained. To calculate a combined certainty factor, we can use the following equation. So the certainty factor sub 1 is the confidence in hypothesis H established by rule number 1. The certainty factor sub 2 is the confidence in hypothesis H established by rule number 2. So the certainty factor sub 1 and certainty factor sub 2 are the absolute magnitude of certainty factor sub 1 and certainty factor sub 2 respectively. The combined certainty factor has three equations. Each equation will be used based on certainty factor of rule number 1 and 2. So the first equation is used if the certainty factor of rule 1 is greater than 0 and certainty factor of rule 2 is greater than 0. The second equation will be used if the certainty factor of rule 1 is less than 0 or the certainty factor of rule 2 is less than 0. So the third equation will be used if the certainty factor of rule 1 is less than 0 and the certainty factor of rule number 2 is less than 0. We assume that certainty factor of evidence sub 1 is equal to certainty factor of evidence sub 2, which is 1.0. To combine the certainty factor, we must first find the certainty factor of rule 1 and 2. So, among the three equations of combined certainty factor, the first one will be used because both certainty factor of rule number 1 and 2 are greater than 0. So the combined certainty factor of rule number 1 and 2 is 0.92. Consider a case when rule certainty factors have the opposite sign. So the certainty factor E sub 1 is equals to 1.0, which is positive, and the certainty factor of evidence sub 2 is equals to negative 0.1. So in this case, the second equation of combined certainty factor is used because one of the evidence, which is evidence sub 2, is less than 0. So the certainty factor, or the combined certainty factor of rule number 1 and 2 is 0.5. Consider a case when rule certainty factor have both negative sign. So the certainty factor E sub 1 is equals to certainty factor E sub 2, which is negative 1.0. So in this case, the third equation of combined certainty factor is used because both evidence of rule number 1 and 2 are less than 0. So the certainty factor of rule number 1 and 2 is negative 0.92. The certainty factors theory provides a practical alternative to Bayesian reasoning. The heuristic manner of combining certainty factors is different from the manner in which they would be combined if they were probabilities. The certainty theory is not mathematically pure, but does mimic the thinking process of a human expert.
Bayesian reasoning versus certainty factor. Bayesian reasoning. Probability theory is the oldest and best established technique to deal with inexact knowledge and random data. It works well in such areas as forecasting and planning, where statistical data is usually available and accurate probability statements can be made. However, in many areas of possible applications of expert systems, reliable statistical information is not available, or we cannot assume the conditional independence of evidence.
Certainty factors. Although the certainty factors approach lacks the mathematical correctness of the probability theory, it outperforms subjective Bayesian reasoning in such areas as diagnostics. Certainty factors are used in cases where the probabilities are not known or are too difficult or expensive to obtain. The certainty factor approach is also provides better explanation of the control flow through a rule-based expert system.